So, welcome everybody. Good morning, good afternoon, however, what time it is on your place. I'd like to welcome you to our second webinar here from Elite Robots Germany. Today's topic, how can we make complex movements easily to a program to an Elite robot? And first of all, it's the first time that we do it in English, so we are happy that Elite Robots Germany can provide a lot of knowledge, a lot of information, a lot of great ideas to all over the world, and can help our colleagues all over the world to create a lot of benefit to you as our customers and interested companies. More or less, I want to welcome in the very first step our special guest Tamas who is in charge for Easy Automator and will show us how to do the easy programming. So thank you very much. He will introduce himself a little bit also later, and also to Uli Möller, who is in charge for Elite Robots marketing in Europe and will do the moderation. From my side, welcome to you again. My name is Jürgen Ostermeier. I'm in charge for Elite Robots Germany with the sales area Europe. Some of you know me, some not. However, now let's start with the most important parts today. A lot of information, and I give the moderation to Uli.
Thank you, Jürgen. Hello, Tamas. Nice to have you here in our office here. And let's talk about the benefit of your solution and something about your company and the setup. So let's go in the details. So first, let's introduce your tool, your Easy Automator.
Yeah, okay. At first, I just start very short with our company. So we are Germany, Bavaria, and Regensburg-based company. This is a young company with the aim that we want to make complex movements and complex complex movements very easy for cobots and for any kind of robot. Okay, so the benefit is of this system that you can really copy any kind of manual movement what a human could do with any kind of manual tool. It doesn't matter if you want to make any kind of deburring or spraying or whatever complex stuff, which would be very challenging to do with the conventional programming method, especially with the robot one, with the Cobot one. And for this, we developed a solution with which you can really copy the arm movements of a human, and you can just transfer it to the Cobot.
Okay, that sounds interesting. And also the big point is you don't need a special tool.
That's true. Halfway, we need a special tool in the sense that we developed a so-called teach pen.
I mean on the customer side to make the job at the end.
No.
You can use the deburring tool, the painting tool that you have in front of.
Yes.
But you automate the process with your special tool.
That's true. That's true. Yeah. Sorry for this misunderstanding. That's true. That means you can use everything from your production. You can use everything from your workshop what you already have. You can use exactly the same technology. So there will be nothing different. What you can do manually by your workers, by your employees, by yourself, you will be able to do this with the Cobot as well, with the same machine, with the same technological steps.
Yes, and now let's talk about the setup. What is necessary to record the movement from the human worker?
Yeah, so for this we really need this kind of special tool. So I just show it to the camera. This is a teach pen, we call it. You can
Bitte Großaufnahme.
You can use it as a right-handed or a left-handed tool. And basically, I'm not sure if you can see this within this room. We have two laser boxes inside, and
I will show it because you see it. The one laser is over there, and the second one is a little bit higher.
Yeah, and with these laser boxes, we can completely scan this room where we are at the moment. And with the teach pen, we will be able to get the laser beams, and based on this, we will be able to capture all of the movements, which I will show you later on live how to do this. Additionally, you need for sure a software. We are using two pieces of software. The one is Robotics, which is a visualization and offline simulation tool. And the other one is the Easy Automator, or with the old brand which I have right now on my PC with the Robotics track tool, which is responsible for the capturing and for the controlling all of this technology. Without the need to write not even one byte, not even one line of code. So programming in this case is not programming. This is a teaching. We are just mimic some movements, and the robot will capture this.
Showing and repeat.
Exactly, exactly.
And that is also a benefit, because some people asking, why should I use this tool? A Cobot is still easy to programming. Where's the benefit of such a tool?
It's exactly, so a Cobot might be very, very easy, especially if you want to make any kind of pick and place applications where you can just use this teach button, and then you can just really drag and drop the robot to the right place. So that's true. But just think about, I just have here a kind of seat with a very complex outline. And you should here in such a kind of outline record a couple of 100 points. So it would take a lot of time. It would consume a lot of time, and not even the accuracy would be so as you imagine, because the Cobot is a little bit heavy to work around. If we are thinking about a different kind of robots, like industry robots, then this might coming to the Mission Impossible. So therefore, I think this is a very helpful and useful tool, because this really gets the job done within minutes.
Yes, that sounds really interesting. And let's talk about what could be the task that could be automated by this tool.
Mm-hmm. So the use cases where we can really recommend it and where our customers are very happy with, this is typically spraying, powder coating, so any kind of manual coating processes where the worker is really coating something. Then deburring and grinding, polishing are they are applications which are most likely used with this stuff. Then you can use it for sure for welding, for dispensing, for gluing. So everywhere where you really have paths or a
Sanding,
line,
polishing,
exactly,
and
where
so on.
Where you have mostly 3D applications, 3D in the terms that this is not just a simple surface what you want to coat, but this is really, there you have some additional geometrical singularities inside. For this is very, very well advised to use this kind of tool.
So enough infos, let's start with the demo.
Let's start with the demo. Before we start with, I would like to show you and highlight it that you can use this tool as in the so-called standalone mode. That means you can really use the teach pen. And we have a couple of different kind of adapters. I'm not sure, I'm just coming a little bit in the near. So you just you can just put the adapter onto the pen, and then you can follow any kind of edges, surfaces, or anything else. So this is a very easy way how you can integrate this tool onto any kind of manual tool. So, and what we already prepared, and I will show you that we have two steps basically what we have to complete before we start with. The one is, and I just would like to come to the camera. And
do you do the task, and I'm the cameraman.
Thank you. So we just have to define this tool on the robot. This can be anything. So this is, just imagine it as it would be your really your work tool, what you are using on the everyday task. And the second one is we have to define the workspace. And the workspace, what you can see here, is defined with 3 points. So we have one origin, we have an X coordinate, and the Y coordinate. In this case, I just put it onto the desk, but you could use any kind. I just prefer to use this kind of wooden plate where I have some pinholes inside, and this is very easy. You can just fix it somewhere in front of the robot, and this will describe your workspace. So I will show you on my screen, and in the reality, I hope we can share the screen. Sorry, I just switched the device on. And we should see on the screen exactly that the teach pen and the two laser boxes are active. So we are ready with the VR environment. And as next, I will just start the Robotics track tool. how to start over the robotic file and all of the definition of TCP and of the frame and everything. For this, we have very detailed explanations on our website. You can find it for free of charge. And we have a YouTube channel where you can really find it live as we show how we move on. So right now, I just opened this up, and you can see I have the pan as the teach pan. I have the robot. I have my tool and I have my workspace, my frame, there's everything defined. And right now I don't have to do anything else. I just hit start recording. Before we start with the real recording, every time we are just doing a kind of initialization. As this is an optical system, we want to know if we have some reflective stuff in the surroundings or anything. So what I will do right now, I'm just following the instructions from the screen. So the first, I'm just coming to the origin, then I'm coming to the X, then you can see I have to follow to the Y. And right now you can see that the robot is already following completely my movement. So the VR system is active, and I'm just coming back to the origin once again. And here you can see, okay, this was not so exact at this moment, that with this trial I have 4.6 millimeters inaccuracy with the optical system, which is not a deal breaker, because we have a lot of so-called afterwork tools, which I will show you later on, with which you can improve the accuracy of the recorded path. Okay, so right now the robot is just following my movements on the screen, and I'm just coming here. Let me see, this will be my home position. And on the screen, you can see that there are many data points are running. I'm just coming with this tool along this edge of this chair, just coming out a little bit. So the recording is ready. So we needed really only just 1 minute, or not even 1 minute, to do so. And here on the screen, you can even follow all of the important information, what you need. So you need if you can see if the teach pen is connected. You see the battery, you see which buttons are used, and all of the technical information, which I don't want to go deep inside at this webinar. It's not the most important stuff. So I just hit finish recording, and you can see on my screen that I have a lot of waypoints here. So and this, yeah, sorry.
Yes, I see the lot of waypoints.
Yeah, and even with this very short outline, we recorded 227 waypoints.
Okay.
And this makes the big difference. Okay, so if you would have to do this with the teach panel or with the free ride mode, this would not take 60 seconds. This would take 60 hours or so. Okay.
Okay.
So the next step is I just check out on the screen if this recording is good enough. And I don't do anything else. I just double click it, and I can see on the screen, okay, the robot is moving around exactly on the waypoints what I wanted to hit. And as next, I just click on the right click, and I just hit send program to robot, which I have just done right now. Done, one file successfully transferred. So that's all. That was the programming part. Okay. Right now, everything what we just created is on the teach panel, and I'm just using it just normal. I'm opening a script file here, and I show you what we recorded. Yes. First, I will show you how it looks like.
So let's take a look.
And the robot is already driving. I'm just having my thumb on the speed setting. If something goes wrong, then I can react. Not only with the emergency stop, but I can just lower the speed. However, I do not expect something bad, but you know, first time to try can always something happen.
Yes, also with the Cobot, safety first.
Exactly. So it looks quite well, I think. For sure, in this case, I was not using any kind of adapter or so, and therefore they are a little bit shaking of my hand with this recording. By the way, we have an additional tool with which you can reduce this kind of shaky movements automatically, so you don't have to go through all of the 230 points.
Yes, and you can see that it's not exactly on the point.
Exactly. And I will just show you as a next step how we can make it different. I don't want to overstress it at this live presentation. I will come a little bit to this direction to be over the edge, and I will just raise a little bit the Z-axis. And I will show you that even this one you can do without any kind of programming skills. So this is our raw file, and I'm just coming to the screen. If you can show my screen, please. And on the screen here, you can see the lot of waypoints which we are just created. So right now, what
You make a kind of calibration.
exactly. So what I have done, or what I will do right now, I will just read out the position of the robot on this particular point.
Yes.
I will transfer it to the program, and I will tell to Robotics, okay, each recorded point, please from the 70, original 70, move to the new 70. So the offset what we had inside, we will just with some mouse clicks, we will just improve it.
And if you do it with a few points, you get a better result.
Exactly. So basically, with very complex tasks, we really recommend that you can even do this with the frame. Okay. So then even the orientation, you can really turn the complete space around. I just don't want to overstress this. I just want to show here how easy it can work.
Yes. Also, the name of the webinar is Easy Automation.
Exactly.
And make complex ways point easy to automate, and so it's deep enough to show it.
Yeah. So I just hit
that way.
Get position, and here on the screen we just seen that the robot position was read out. Okay.
Yes.
And then I just hit here. I just rename it, and I say this is the P70 new, that I don't forget. And I just teach this position with a simple mouse click. Teach current position. Bam. So this new position was just saved, and I just record or select all of the waypoints, and I'm coming to this Afterwork Tools folder, which I already mentioned. So you can see here we have a couple of tools: align the waypoint, copy the tool orientation to the tool. You can, with the Afterwork Tools, you can integrate the teach pen to any kind of manual tool. There are a lot of functionalities. At this, in this particular case, I just choose the improve accuracy. it's just starting. And here I already selected all the waypoints I want to modify. I just select the waypoint 70, which is my from waypoint, so this was the original one. And I'm just select the new one as the 2. And I just remove the I just want to show you for our guests how it will work. So once I hit the execute, all of the waypoints will be recalculated and shifted to a new position. You can see this. So this is shifted on the Y or on Z axis to the top, and this was coming a little bit to my direction that we can fix this out. The process is successfully done.
Okay.
And right now I don't have to do anything else. I just send the robot program again, which is completed. And I just coming to the teach panel and I just reread the script and we will see what we created. Okay, seems to be fine. And I just start over. We are using always a particular home position, which I already predefined here, just for safety reasons, just for avoiding kind of singularity problems. This is not a 100% solution, but this is a very good workaround. And here we can see that the robot is right now really going along the edge of the chair, a little bit higher, as we just shown this. Here there was the point where I just coming just to show the 3D capabilities of the tool. And that's all. So if we would take additional 20 minutes for this, we could go really exactly along the line, and then you can really make any kind of complex movement, and you can align it to the maximum accuracy what you want to reach. This is for sure always depending a little bit on the capabilities of the device, for sure, but there are no principal limits. So if you can go there with the teach panel, then you will be able to teach for the robot the new position, and you can even select if you want to work with each of the recorded points or with just some selected points. So this is always depending on the application.
And the accuracy from the optical device was in a few millimeters.
Exactly. In this particular case, I think I have approximately 4 millimeters.
Okay.
This is normal, so we specify it in a way that approximately 3 up to 4 millimeters should be normal. If we are taking care a little bit about that, we don't have reflective stuff in the surroundings or any kind of disturbing elements, then normally we are coming to the region of 1 millimeter. However, please always keep in mind, this is a freehand process. So if you don't have any kind of template to follow, then this kind of inaccuracy is always there. But as we have the tools to improve the accuracy, we don't want to be over accurate with the out-of-the-box recording.
Yes, and at the end, if you make a powder process, you don't have to be in millimeter size.
Exactly, exactly. This is the next one. And this is what I wanted to show you additionally. I just drive away with the Cobot a little bit for a recording. So what I already mentioned you can integrate our teach pen onto any kind of manual tool. I just solved it with 2 magnets, so this is so easy. I would not recommend it for the daily usage, okay, because this is too unprecise. But even with the 2 magnets, you can do this. I just come a little bit too near. So this is a spray gun from Kreuzberger, a normal one, and you can just simply pick it with the magnets. We have in our tool the capability to save all of the recorded manual tools, which I show you right now. So I start my program again.
Yes.
And here I just have to go into the options menu, and I can select all of the pre-recorded stuff. This is the Kreuzberger spray gun.
Okay, can I
Sure,
create the record?
Sure, yeah.
So I have to push the button? Also where it's spray and where it's not spray?
Actually, with this one, this will not work. So you have to go to this button, please.
This one in the front?
Yeah, this one in the front. So what you will have to do at the very beginning, you're just coming with the middle of the spray gun to here. You just press this button.
Oh, I don't see it.
Never mind. This will be a little bit inaccurate, but never mind. So wait a second, I just started. So right now, please come to the origin and then...
I press the button?
Yeah, press the button. Come to the X, press the button.
Press the button.
Come to the Y, press the button. Exactly, and come back to the origin, please, and press the button again.
This is a pre-post?
Yeah, come back to
this
here.
one.
Yeah.
This one again.
Yeah.
Oh, sorry.
Okay, so this was a little bit inaccurate. I think you just press the button in between. Yeah, we have 350 millimeters inaccuracy in between.
Okay.
Never mind. We just test it. Okay, we just test it. So I just I just press you the toggle path track, and then you can move. You should, don't press anything. I'll just do this for you.
Okay.
And right now you can spray. Okay.
Okay.
So we just check this out if it works.
So I can lay it back?
Yeah, you can lay it back.
Okay.
I'm not sure. It just seems to be crashing. But never mind, because we already have the recording. So this is what you recorded. We will test it very slowly. Because
I make the record.
No. I guess that we will just hit the desk, but we will test this out, okay?
Okay.
We just take a quick test on this. So send the robot program. Okay. I just read it in. But to be very fair and honest, this was the very first time that you use this tool with an external manual tool, okay?
Yes, I didn't use it any time before. We have seen us a few years ago.
Exactly.
But that was at a pub.
That's true. Where should we talk about robotics if not in a pub?
Yes.
Okay.
Crazy guys talking about robots in a pub.
Okay, so the little bit strange position of the processing head is really depending on this accuracy, which we just have seen at the very beginning. But you can see that the hand movement of yours is exactly followed by the robot. Mm-hmm. So even with this approximately 30 centimeters inaccuracy, what we just captured it with this trial, it doesn't disturb on this for a spraying process that you can get exceptional results. If you have a little bit exercise with the tool, then you are really coming regularly to 3 up to 5 millimeters, which is more than enough to complete any kind of spray jobs.
But we want to show a real use case, and so I didn't try it before.
And this was a good point as well. This happens at our customers sometimes as well, that the recording is running, and you are just coming into a position where the robot will crash on itself. I've seen on the screen at the simulation that this will happen, so we have a collision detection as well. But I didn't want to show this directly here on the screen because then we can't move on quite quickly. But I think that's fine because then we have seen even though this is a Cobot, so it stopped. We didn't hurt anything. We didn't crash anything. Right now, for sure, we just have to restart the Cobot again, and then we are ready to go. Yeah?
Yes. I was phoned with a friend of mine with a robot palletation. He had created a crash, €5,000 again.
Yeah.
So Cobot is something else.
Yeah. This can happen. So, but basically, I think you get the idea. How about is this? I think this is very important to mention, especially at this English language webinar. Right now, we are just demonstrating on a CS series. But we tested several times on the EC series, and it works exactly the same good way. So EC, CS series from Elite, but all of the devices are 100% supported. As you have very good programmers, there are always some additional new features on the post-processor, on the driver, so you get always new features as well. Maybe one stuff which might be interesting for some visitors or attendees, you can even record the speed of the movements if you want. And afterwards, as I have already shown you, you can one by one change any kind of parameter, waypoints, speed, anything what you want. You can change afterwards once you are not satisfied. So in this case, this would be the stop point, and then we just not crash at every new workpiece.
Okay, as you can see, it's a real cool and easy way to program complex wavepoints to a robot and also a cobot. And I think we are quite on the finishing line. Maybe Jürgen,
Yes.
something else to add on?
Is the microphone working when I speak to your chest? I hope so.
I
Yeah,
can help you.
Thank you very much, Tamas, for this presentation. Thank you very much, Uli, for this moderation. It's not the first time that I see it, but I'm always impressed again. Yeah, it's really easy. So to put it from my perspective into one sentence, making 207 waypoints in 30 seconds, it's awesome. Yeah, that helps a lot. And yeah, what Jürgen, I'm standing for efficiency, for low cost, for performance. Yeah, all the companies all over the world, we get more and more pressure about time, about money, and this can help all of us to be more efficient and more sustainable on the market and the high market pressure at the moment. So thank you very much. There was one question coming up here to the mind. You always press the button send to the Cobot. Is it by Wi-Fi? Is it by do you transfer the data to our robot?
This is the only stuff which is an old-fashioned way at our software solution. This is really done by wire. This is so that we need a direct network connection to the robot controller, which works with all of the Elite devices very well. And we need an active internet connection because of the licenses, as we are using external software as well. But the transfer of the data and to read out the position of the robot and everything, this is running over the wire. This would be even, I think, a kind of safety concern if it would be a wireless one. It would be doable if you want.
Cable is not always bad.
But this is the cable solution, and it works very well.
No, very good. Yeah, that also suits perfect to our idea to also have a good connectivity to different products. Thank you very much. And one last question comes to the mind here from the audience. Yeah, it's all about the money. How much do you need for the investment? How often do you need to buy it? What is your way of using it in combination with the robot?
Yeah, thank you for this question, and I think this is really important. So we have a time-based model. That means you can have different kind of licenses for 1 week, for 1 month, for 1 year, depending on the needs what you have. If you just need it occasionally, then you are ready to go with a 1 week license. Just let it in the cabinet for a couple of months, and then you can get the next ticket. Basically, we offer an all-inclusive package as well, with the Robotics software, with our software, with the hardware kit for sure, what you need for, and with 1 year usage, even longer. And for the attendees of this webinar, I would really offer with Elite Robots 30, with this promotional code, if you come to us, then we will give you a starter package with 30 days usage ticket, which is the normal one, and we give on top 30 days additionally for our visitors.
That's quite awesome, and that's what we want. Hey, try something without any risk. You know, we can promise everything. So my recommendation to you, audience, try it. Yeah. Finally, thank you very much, Tamas. Thank you very much, Uli. Get in contact with Elite Robots or with Tamas. We are in deep contact and share all the information. For me, nothing more to say. Thank you very much, and see you soon in our next webinar in the
next LinkedIn Live.
In the next LinkedIn live event, and in about 1 month.
Exactly.
Thank you very much for your invitation.